Okay, I actually want to back up just a little bit and get an overview of the errors and truths in hypothesis testing. First of all, we can have which hypothesis is true in reality, which we won't know, but let's suppose that HO really is true. Well, if we fail to reject HO, then there's no error. We fail to reject HO, and HO is true. No error there. The probability, if HO is true, here we reject HO, we support H1, we reject HO, so there's a potential then that we've made a type 1 error, and the probability of that error is alpha. So if HO is true, we might not make an error. If HO is true and we do make an error, it's a type 1 error, and the probability is alpha. Again, that's all based on the distribution of the null of HO. That's the distribution if HO is true. Sorry about that. So now let's suppose that HO isn't true and that instead the alternative, H1 or HA, whatever you want to call it, is true. Well, if H1 is true and we support H1, again, there's no error. And the likelihood, the probability that we will get H1, say it's true when it really is true, is the power of the test. Well, if H1 is true and you're wrong, then you've made a type 2 error, and the probability of that is beta. When we compute probabilities here, the power and the beta, we do that based on the distribution as if a specific HA is true. Now in reality, we'll have just HO. HA will be actually a range of things, and this beta actually turns out to be a curve because we would compute it for every possible H1 if we didn't really know what it was. Here we're assuming that we really do, or that for a given true H1 that we would compute a beta probability of type 2 error and the power of the test to detect a true alternative hypothesis. Okay, so here we have just type 1 error. That means that the distribution I have right here is the distribution based on the null hypothesis being true. Say HO is correct, and we're going to set a type 1 error to some amount. This is something we have some control on. We set it, and we'll get to the whole applet here in a minute, but I set it at 5%, 0.05. That's a common value. So this area in the red would be the probability of a type 1 error. Of course, if we get anywhere in here in the blue area, HO, we would fail to reject HO, assume that HO could be true, and this would be the probability then that we would make that correct decision. Over here you can see this is the H1 distribution. I drew it far away here, so if this is true, we'll always find it, and there's no type 1 error because they're so far apart. Okay, but for right now, just focus on this is the null hypothesis, or this is the distribution. Almost got ahead of myself there. This is the distribution that we are computing things from, assuming HO is true, that the null hypothesis is true. Okay, so type 2 error. Now we still have the HO was correct distribution, and we still have the probability that we're right, and then we have the type 1 error, or alpha. Now we have something else here. Isn't much of a change from what we had before. If we do reject HO, it's out here, we will get this one, since it's all the way right down here almost at the asymptote. We actually will never make an error in this case either. There's no type 2 error, and the power of the test is 1. So let's go to a different picture here. Now we have a little bit of overlap. So remember, this cutoff line here, the red line, is where we will reject HO. So the type 1 error is in the red. So that's type 1. Then all of this would be correct if HO was true. Now let's suppose that this alternative distribution is true. Well, anywhere below the red line, we would fail to reject HO, so any of this area in the yellow is an error, because if this one's true, down here we say it's this one, so we have this chance of making an error. And I'm just using sliders to get to this and reading it off here. The probability of a type 2 error in this case is 10%. Don't worry about the calculation of these, especially not with the normal distribution yet. I showed you how to do it in the previous video with the binomial distribution. And then the power of the test is 90%, or just 1 minus the yellow, so anywhere from here up we would reject HO. Oh, sorry, went to the wrong. I'm getting a little trigger happy with my mouse here. Anywhere up here, if this is the true distribution, we've rejected HO, concluded this is true, so we will have concluded that we're in this distribution, if it's true, 90% of the time. Okay. Things get a little bit tougher here because there's more overlap. So still have the type 1 error, but because there's so much overlap, let's say that this second distribution really is true. Well, it's going to be harder to detect it. In fact, since we don't reject HO until we get to this point, we will actually fail to detect that this second distribution is correct almost 85% of the time. And the likelihood that we will find this effect, if it's really there, is only 15 or 15% of the time. Okay, so this is the a link to the applet where I got that, and I'm going to just show you one other thing on this. Bring that over here. Okay, so here's what I was doing on that. I can move this out to get the type 1 error at 5% roughly, and then I can move this distribution around. So out here, 100% chance that we're going to get, if this is true, we'll find it. But as we get more and more overlap, the power of the test now is only 95%. Again, that's this area over here. Notice that the type 1 error remains at 5% the whole time. Now if we have more and more overlap, it gets harder and harder to see that this is the real distribution because we're just not that far off. And again, it gets even further. So here we only are going to correctly detect the alternative distribution about 11% of the time. Now I'm going to show you one other thing. This will become more important later in the course. But if our sample size goes up, look what happens to the shape of those curves. So now, look what happened to the... okay, I see we didn't have a... What I have to do is now readjust over here to type 1 error of 0.05 or 5%, because the curve is moved. When you get up, I'm not going to get that close. That's close enough. You can see now the power of the test is 27% instead of 11, and the type 2 error has gone down. Let's make this a little bit more. Here now we have power of test, let's get it a little bit closer here, of about 70%. Now when we raise the sample size, oops, sorry, I got the wrong one. Well, that was good. Got to get this to 05 again. You can see why I try to do when I'm doing this one live instead of let's put it here. The power of the test is 36%. Now I'm going to take this up, move the alpha back to 0.05 or to 5%. And you can see that the power of the test now has gone way up to 81% because the narrower curves make it easier to see that there is a difference between the two. So you can think of it this way, that the larger your sample is, the greater amount of information you have. So for the same size difference between means, the means of these two distributions were the same whether we were at this sample size or that one. But the more information we get from the sample size, the more and more likely it is that we will find a true effect if it does in fact exist. Back over here. I think I'll do that in another